Welcome to the Merlin and Metro News Network. Today's program begins our series of programs on the landing gear system. The landing gear system is only used twice during every flight and yet has a critical effect on aircraft safety. Because the landing gear system is largely mechanical, it requires both inspection and routine maintenance. And this is an important part to remember because most problems with the gear system can be traced back to poor maintenance or inadequate inspection. Our program today will cover the basic principles of how the landing gear extension and retraction mechanism operates. Now let's roll the first program.
The landing gear system is of vital importance to the Merlin and Metro aircraft. Landing and takeoff operations are the most dangerous periods of flight for an aircraft. And the landing gear system plays the major part in both of these activities. Besides just supporting the aircraft, related landing gear systems also provide a means to stop and steer the aircraft. The operational status of all landing gear systems must be indicated to the pilot, and emergency means to operate critical systems must be supplied. Also critical to the operation of the system is the mechanism to extend and retract the landing gear during flight. Hydraulic actuators are installed on each gear to extend and retract it, while mechanical locks are used to hold it in either position. This process, from locking the gear extended to retraction in flight to locking the gear in the retracted position, is the subject of today's program. Gear operation may be divided into the following phases. Down and locked is when the gear is fully in the down position and is both mechanically and hydraulically locked in the down position. Up and locked is when the gear is fully in the up position and is mechanically locked in the up position. Pressure trapped in the hydraulic system may cause the gear to be hydraulically locked in the up position as well. In transit is the condition when the gear is not in either the fully down and locked or fully up and locked position. The pilot is informed of the status of each landing gear through a cockpit indicator. When the gear is down and locked, a green light for the respective gear will illuminate. When the gear is in transit, a red light will illuminate. When the gear is fully up and locked, all lights for the respective gear will extinguish. Whether discussing either the main gear or the nose gear, many similarities exist. Each gear consists of two major assemblies. The landing gear strut absorbs the loads applied during landing and takeoff, supports the axle for the wheels and tires, and supports the weight of the aircraft. The drag brace is used to lock the gear in a vertical position and to be used as part of the mechanical system that extends and retracts the gear. The strut and drag brace work together, exactly the same as this folding table leg. The leg collapses by having the brace fold, which is exactly the same as the drag brace does during gear retraction. When the table leg is extended, the leg brace travels over center and locks mechanically. When a device is said to be over center, we mean that the center hinged point of a hinged link has traveled beyond its normal, fully extended position. The result of this action is as follows. Before reaching the over center position, we can fold the leg by pushing on it. After our brace has traveled over center, we can no longer fold the leg by pushing on it. When the gear is extended, the drag brace travels over center and mechanically locks in position. The strut cannot retract with the drag brace in an over-center condition. By keeping the drag brace locked, we are in fact keeping the gear locked. When the table leg is folded, it is mechanically locked in the folded position. When the gear is retracted, it is mechanically locked in the retracted position. The power to fold the table legs comes from hand or foot power. The power to extend and retract the gear is supplied by these actuators. Both actuators are used to retract the gear, while only one actuator is used to extend the gear. This is because the air loads work against retracting the gear, while these same loads greatly assist in the extension effort. An additional consideration in the landing gear system are the landing gear doors. The doors must be fully open during gear retraction and extension and closed after gear retraction. The main gear doors also close after the gear is extended to reduce drag. The operation of the gear doors is mechanical and is actuated by movement of the gear. Other characteristics common to both the main and nose gear include an actuator bell crank. The bell crank is installed on a pivot on each nacelle keelson. One end of the bell crank is connected to one side of the actuator through a pivot. The other side of the bell crank is a roller that will be used to lock the landing gear drag brace in the down position. It is also part of the mechanism that will begin the landing gear unlocking process. It should be noted that the bell crank is connected to a spring that is used to hold the bell crank in the down and locked position. Note also that in one direction of travel, the bell crank will hit a fixed stop, while the maximum amount of travel in the opposite direction will be determined by the adjusted length of the actuator. This adjusted length plays an important part in the rigging of both the main and nose gear mechanism. Working in conjunction with the actuator bell crank is a cam installed on the drag brace. The cams for the nose and main gear are of different shape. These cams are used as part of the landing gear downlock mechanism and are used to help begin the gear extension and retraction process. With the actuator connected to both the strut and the bell crank, we now have a means to retract and extend the gear. We're going to move the gear through the extended and retracted position using a hand pump. Note the relationship between the cam and the bell crank actuator during extension and retraction. When the actuator is fully extended, the actuator bell crank roller is positioned so that it is directly in the path of the drag brace cam. This is the arc of movement that the cam must follow as the gear retracts. The actuator bell crank is located at a direct right angle to this arc, which means the drag brace cam cannot rotate, and therefore the gear does not retract with the bell crank in this position. Before any retraction of the gear can begin, the bell crank actuator must rotate out of this position to provide room for the bell crank cam to begin its rotation. Up to now, we have used a main gear mechanism, but the nose gear operation is nearly identical. Again, the gear is locked down through the combination of the drag brace cam and the actuator bell crank. In either the main or nose gear installation, it is important to remember that the position of the actuator bell crank to the drag brace cam performs the downlock function, and that the extended length of the actuator will determine the position of the actuator bell crank. The next major consideration is a means to lock the gear in the up position. This is accomplished through the use of a mechanical up lock installed on the drag brace of the gear. While some differences between the nose and main gear up lock mechanism exist, their operation is fundamentally the same. An up lock hook is installed on a shaft located on the drag brace. Springs are installed on the shaft to preload it to the lock position. An up lock roller is installed on the gear strut, which will engage the up lock hook. During retraction, the roller will first engage the portion of the up lock hook that serves as a ramp. As retraction continues, the travel of the up lock roller up the ramp will cause the up lock hook to rotate. When the travel of the roller reaches the end of the ramp, the spring-loaded up lock hook will be rotated into position and capture the roller. Here is a nose gear strut being manually retracted. Note that even though the roller is in a different location and the up lock hook is shaped slightly different, the resulting action is the same. Now that the gear is up and locked, the next consideration is unlocking it to begin the extension process. This is accomplished through different mechanisms on the main and nose gear. In both cases, it is the rotation of the actuator bell crank that unlocks the gear. Remember, as the gear retracts, the bell cranks begin rotating as a respective actuator begins retracting. The rotation of the bell crank continues until it reaches a hard stop. When gear extension begins, the first action will be that as the actuator begins to extend, the bell crank will rotate back towards the down position. This initial movement is what is used to unlock the gear. Let's consider the main gear installation first. Returning to our up lock hook assembly, we find a release arm attached to the shaft. If this arm is pushed in this direction, it will cause rotation of the up lock hook assembly. If the arm is pushed in this direction while the gear is up and locked, the result will be to free the up lock roller and unlock the gear. To cause this rotation, another component is installed on the bell crank cam. This striker arm will be hit by the bell crank as extension begins. We'll move the mechanism slowly by hand so you can observe the operation. Let's follow the action step by step. When the landing gear actuator begins extending, it causes the bell crank to begin rotating towards the down position. As the bell crank rotates, it will hit the striker arm installed on the drag brace cam. The striker arm will in turn force the up lock shaft to begin rotation towards the unlock position. When the up lock hook shaft has rotated sufficiently, the capture of the up lock roller will be lost and the gear extension will begin. As the gear extension continues, the up lock assembly is now inactive and totally disconnected from any other further activity in the gear cycle. Now let's look at the nose gear up lock release mechanism. Because of the different length and shape of the nose gear drag brace, the unlock mechanism has to be slightly different than the mains. Just like the mains, a striker arm is installed on the drag brace cam. But it is physically connected to the up lock hook shaft through the use of this link arm, connected to a fitting on the end of the up lock shaft. If the striker arm is pushed in this direction, it will rotate the uplock hook to the unlocked position. Again, the rotation of the actuator bell crank provides the means to unlock the gear. During gear extension, as the actuator extends, it causes the bell crank to begin rotating towards the down position. As the bell crank rotates, it will hit the striker arm and begin pushing it out of the bell crank's path. The displacement of the striker arm will begin rotating the uplock hook. Once the hook has rotated sufficiently, capture of the uplock roller will be lost and the extension process will begin.
The basic design of the strut and drag brace have not changed substantially since the prototype Merlin and Metro. However, some of you may have noticed a strut and drag brace that appear physically different. As part of a continuing effort to update the Metro, an option to increase the maximum takeoff gross weight to 16,000 pounds has been developed. While no changes were needed for the nose gear, the main gear strut and drag brace were substantially beefed up. Although these struts appear physically different, their operation and function are exactly the same. And now let's return to our program.
We will now follow each gear through a complete cycle. We'll begin with the gear down and hydraulic pressure applied. Each landing gear actuator will be in its most fully extended position. The landing gear cannot retract into the wheel well because the drag brace is in the over-center position. The drag brace cannot move from the over-center position because the actuator bell crank position prevents the cam attached to the drag brace from moving. The gear up process begins with the pilot moving the gear handle to the up position. This causes the hydraulic pack to direct pressure to the upside of the landing gear actuator. This pressure causes the actuators to begin retracting. As the cylinders retract, they cause the actuator bell cranks to begin rotation. As the bell cranks move, they unlock the drag brace cam. However, actual retraction does not begin at this point. As the bell crank rotation continues, it will eventually contact the other side of the drag brace cam. The bell crank roller contacts and begins pushing the drag brace cam, which will move the drag brace from the over-center condition and begin the gear retraction process. As the actuator retracts and the drag brace folds, the gear begins retracting into the wheel well. The gear now enters the wheel well. The folded drag brace now positions the uplock hook to capture the uplock roller. Here is a main gear being locked in the up position, while here is the nose gear. Each gear is now in the fully up and locked position. The gear down cycle begins with the pilot moving the landing gear handle to the down position. This causes hydraulic pressure to be supplied to the extend side of the gear actuators. This pressure causes the actuators to begin extending. As the cylinders extend, they cause the actuator bell cranks to begin rotation. As the actuator bell cranks rotate, they actuate the mechanisms to release the uplock hook. Here is the main gear uplock being released, while here is the nose gear release. With the uplock released, a combination of gravity, air pressure, and the extending hydraulic actuator will push the strut towards the down position. Once the strut is fully extended, The final rotation of the actuator bell crank locks the drag brace in the down position. Remember that only one actuator is hydraulically powered in the down position. If the normal hydraulic system is being used, the powered actuator is as shown. If the emergency hand pump is being used, the powered actuator is as shown.
Well, that covers the basic extension and retraction operation of the gear. By now you should be familiar with how the gear is locked in both the up and down positions, how the up-lock hook is released normally, and how the drag brace prevents the gear from retracting. Our next program will cover the gear door system, indication system, and emergency extension system. Until then, good flying and good maintenance.